Good morning, everybody. I want to welcome us all again to today's class, Computer and Statistics. So last week we introduced sampling, we introduced statistics last week, and we tried to define what statistics is. We looked at the origin and growth of statistics. We looked at the various definitions according to different persons, and then we looked at the four stages of involved in statistics, which has to do with collection of data, analyze the presentation of this data, analysis of the data, and of course interpretation. We tried to explain it last week. Then we also looked at the functions of sampling, talked about condensation, being able to enlarge data, heterogeneous data, being able to compress it to the form that it can be presented and analyzed. We talked about comparison. Sampling is actually used to compare between two items. Okay, then we talked about forecasting. I give example like the meteorology, being able to forecast the weather for tomorrow, for next week, like that. And then of course estimation. Okay, and other things I looked at. Okay, then we also looked at applications of statistics in industry. Applications of statistics, we looked at statistics in manufacturing, in engineering, in commerce, in agriculture, in economics, in education, in planning, in medicine, and of course in other areas. We also looked at the limitations of statistics. We talked about that statistics does not study individual. Okay, there's no particular law, exact law that is guiding statistics. So the result of any statistical process or procedure is determined by the person who carried it out, as long as it's a standard you can follow. I talked about statistics being misused sometimes and used to create panic and the rest of them. So those are the highlights of what we did last week. So we're going to be building that from here. So today we're looking at the introduction to sampling method. Introduction to sampling method. Now, sampling, as we all know, has a wide application in our daily lives. Sometimes we don't know that what we do when we go to the market or to the supermarket to buy food items, we actually use statistics, okay, in doing that. For example, you want to buy 10 cups of rice. The first thing that when you walk into the mall or to the seller, the first thing you look at is the quality of the rice grain that the person is selling. So you have to be first of all convinced that the quality of the rice is okay for you to buy. And then by the time you tell the woman to measure 10 cups, your eyes is fixed at the cup to be sure that what the woman is measuring is actually 10 cups, talking about the quantity. So you see, sampling has a lot of applications in everyday life. You go to the hospital and you're sick. The first thing the doctor says, he subjects you to diagnosis. They take a blood sample, okay, then run a test. That's part of sampling. Okay, so we're going to be looking at today's class, we're going to be looking at the importance of statistics, the various importance of sampling, the various methods of sample selection from the population, and then as well discussing the various methods, we also look at the advantages and limitations. All right. So in sampling, the first thing that comes to mind is population. So we're going to define some terms as far as sampling is concerned. The first is population, just as you have in my slide. You said population has to do with the complete set of all possible observations of the type which is to be investigated. That's population. The totality of what you want to investigate. That gives us a definition of population. Okay, you want to make an inquiry about something. The totality of what makes up that particular thing that you want to inquire about becomes your population. Okay, that's how we define population. The total number of, for example, total number of students studying in a school is an example of population. Let's say, for example, now there's something you want to carry out in the school. How many persons are offering chemistry? Okay, your population, therefore, now is the total number of students in that particular school. Okay, they're studying chemistry. Okay, another example is your blood constitution. The blood constituent in your body becomes the population. The entire blood constitution of your body is the population. Okay, total number of books in the library, total number of houses in the village or town. These are examples of population. So the totality of items that falls within the purview of inquiry, that falls within the scope of inquiry, is what referred to as the population. Okay. Now, population want us to note the following: that one, when it is possible and practical to examine every person or item in a population, okay, we describe that as a complete enumeration of census. So the population, for example, if it's possible to study, to undertake or describe every item that makes up that population, such population is referred to as census. You know the census that was done in Nigeria some time ago, they went from houses to the other. Now everybody was captured because this was done houses by houses, villages to villages, cities to cities, and everything. So if it is possible to identify, describe every person or item that falls within a population, such is referred to as a census. Okay, like if you go to a school, just like we said, we want to study the number of persons that want to undertake a study of those offering chemistry, and the population is about let's say 3,000 particular school. Okay, and you're able to describe everybody by studying chemistry. Such is referred to as a census. But when it is not possible to measure every item in a population, it is called sampling. So you have to take a sample. That's why when you go to the hospital, the doctor doesn't need to extract all the blood constitution in your system. It's not possible. Okay, otherwise the patient will just die. So it's not possible to now examine the entire blood constituents or constitution in your body. So what he does is going to collect a sample. He just pick a sample. That sample will now represent the entire information about population. So when it's not possible to measure every item, it is called sampling. But when it is possible to measure every item in a population, it is referred to as census. Okay. So population refers not only to people, but to all items that have been chosen for study. So we don't just refer population to the number of people. It can also be represented as number of items, okay, found within an area. So it's not just population is not just referred to people only, but everything, anything that comes under investigation as far as statistics is concerned is referred to as population. So the total number of units in a population is called population size. So what's the population size of this group? 5,000, because the entire number of units that make up that population is 5,000. So we can now say the population size of that school is 5,000. All right, so let's proceed. So we have the finite population and we have the infinite population. Okay, the finite and the infinite population. Now, a population is said to be infinite. It is said to be finite if it consists of finite number of units. That is, if it consists of numbers, the number of units that can be measured, that can be counted, just like I said, for census, for example. Okay, you can count it. Numbers that are finite are numbers that can be counted from 1 to the last number. We said that number is a finite number, 1 to 100, 1 to 1,000, 1 to 100,000. As long as, excuse me, as long as you can count every unit that make up that particular number, it's called a finite. For example, number of workers in a factory, production of articles in a particular day for a company. These are all examples of finite population. Why? Because every single unit of that population can be counted. But a population is said to be infinite if the numbers are infinite, meaning it's uncountable. Infinite numbers, meaning the units of the numbers of units are uncountable. You cannot count them. Example, the number of stars in the sky. Okay, the number of people seeing a television program. Imagine you want to pick a statistics of number of persons watching CNN at a particular point in time. Where will you start from? Is it Nigeria or US or UK or Canada? So that becomes an infinite population because it's not possible to get it. Even in Nigeria, then super story that was actually going on then. It's not possible to know the number of persons seeing that particular program at that particular time. So any population that is uncountable is referred to as infinite population. Then the ones that are countable are referred to as a finite population. All right, let's proceed. So there are two ways of collecting information in a population, just like I've told you earlier on. Two ways of collecting information in a population. They are the census method and the sampling method. The census method and the sampling method. So if you want to get information about a population, there are two ways you can collect such information. The census method and the sample method. Now for census method, every element of the population is included in the investigation. Every element of that population is included in that investigation. So meaning such population is a finite population. That population is a finite population. So that's why you can use census method. So as long as you can count, you can take all the units that make up that population, you can therefore use the census method. Like we have the example now, if we study the average annual income of families, the families of a particular village or area, and there are 1,000 families in that area, it's easy. You can study all of them, all the families. Because why? We've been able to determine the total number of families living in that particular village or area, which is 1,000. So it's a finite population. So if we have to study the annual income, the average annual income of these families in this village, it's very, very easy to just include everybody, to take everybody. Okay, so such type of finite population, you can use census method to actually collect information or to carry out an investigation. So with this, no family is left out. All the family units are included in such investigation. So that's number one method of carrying out an investigation in a population. Let's look at the advantages now, the merits of census method. Look at the merits of using census method. Number one, the data are collected from each and every item of the population. We said it's a finite population, so nobody's left out. Every unit is represented. Okay, so that's number one, a merit or advantage of census method. The data that are collected from each and every item of the population is possible. Then number two, the results are more accurate and reliable because every item of the universe is required. So you are sure of getting accurate and reliable results. Why? Because every member, every unit of that population has been investigated. That's part of the investigation. Okay. Intensive study also is possible because it's a finite population. So you can actually carry out an intensive study. You can pay more attention to such study. You can even bring out more hypotheses. You can bring up more things you're going to use to study. Why? Because you're dealing with a finite population. Okay. The data collected may also be used for various surveys and analysis. Okay, because of finite population. So those are the merits of census method. I said the data are collected from each and every item of the population. The results are more accurate and reliable because every item of the universe is required. Intensive study is possible, and of course, data collected may also be used for various surveys and analysis. Now, remember the example we gave is we want to check the average income, annual salary of the population of that particular village. You can decide to do any other analysis other than that. Okay, feeding habits, uh, health, um, their health status of the entire village. So you can actually carry out any kind of analysis using the same data that is collected. So the data collected is not just limited to one. You're dealing with a finite population. So you can use that same data to run other analysis, to do other surveys, and the rest of it. Those are the merits of a census method. Then what are the limitations of census method? It requires a large number of enumerators, and it is costly. It is a costly method. How many persons are you going to employ during the census population? You know how many persons were involved? Because we're dealing with 1,000 families now, and maybe you have a limited number, limited time, okay, to collect such such population, such information. You need a lot of persons, okay. So that's number one. So it requires a large number of persons to collect such information. And this can be very costly because the more persons you have, the more money you're going to spend. It requires more money, labor, time, and energy because everybody wants to be, nobody wants to be left out in that particular information. Okay, so more money is required, more labor consumes time, energy. Okay, then it is not possible in some circumstances where the universe is infinite. Of course, when the population is infinite, it's uncountable, census method cannot be used. So you see that census method is only limited to a finite population. Anything outside that census method cannot be used or is not applicable. Right? So those are the three major limitations of census method. You said it requires a large number of enumerators, that is people going about collecting such informations, and it consumes time, it consumes money, it dissipates energy, and then it's also limited to just a finite population. Outside that, you won't be able to do that. So these are the limitations of census method. So quickly, let's go to the second method of collecting information in a population. So we are done with the census method. So the second method of collecting information in a population is the sample method. Okay, sample method, according to statisticians, involves or describes a portion chosen from the population. Okay, this is usually done because the population is infinite. It is not possible to use all the units or to include all the elements of the population. So what we just do is to collect a portion from that population. Now that portion you collected will now represent the entire population. Okay, so when you a finite subset of a particular individual define the population is called the sample. So that finite subset, that number now, if let's say for example, now because they're uncountable, we're talking about tens of millions. Okay, and there's always going to include all the 10 million or tens of millions of people. You now decide to collect 100 out of the 10 million. That 100 becomes a finite subset, and that particular 100 represents your sample. That's what we mean. Okay, so sample method is usually used when the population is infinite. Okay, the number of units in a sample is called the sample size. So that 100 that you collected out of 10 million, 10 million and counting is your sample size. How that's clear? All right. So what are the advantages? Now let's look at the merits. Okay, before we get to the merits, let's look at the sampling unit. The constraints of the population, which are individuals to be sampled from the population and cannot be further subdivided for the purpose of the sampling at the time called sampling units. Okay, so each of that 100 persons now that you collected are referred to as the units of that sample, referred to as sample units. So for example, now to know the average income per family, the head of the family is a sample unit. You don't want to involve everybody. Okay, you just go to every family, one person. That one person is actually a unit of the 100 families that you want to use. Okay, so each of that unit is your sampling unit. Let's say, for example, in a village, you picked a sample of 100. Now, this 100 person that you picked to represent your sample represent 100 families. So you just picked one person from each family, one person from each family. So it's possible in a family they have to 10, some up to 15, some have 5, the rest of them. But you're picking one person to represent that family. So each of that one person you picked from there for that 100 persons you want to use is a unit. You cannot divide that one person again you cannot divide it further again. You're not going to split the person into two. So the smallest indivisible portion, okay, of a sample is referred to as sampling unit. Okay, remember, like I said, this is actually done when the population is finite. Okay, then your sampling frame. For adopting any sampling procedure, it is essential to have a list identifying each sampling unit by number. Such a list or map is called a sampling frame. Example, a list of voters, a list of householders, a list of villagers in the district, a list of farmers. All these are examples of a sampling frame. So that 100 persons you picked that represent your sample, you give it a title. Okay, you tell us what you want to do with that 100 persons that make up your sample is referred to as a sampling frame. You want to determine the average income of the villagers using 100 persons as a case study. That becomes a sampling frame. So that in case you want to use that same data to run that thing, you'll be able to know what you want to use it for. Okay, so once you adopt a sampling procedure, which is used to identify sample units, okay, each sampling unit by number is referred to as sampling frame. Okay, let's proceed. So reasons for selecting a sample. Why do we need to select a sample? Number one, complete enumerations are practically impossible when the population is infinite. So one of the advantages of census method is because the population is finite, it is possible to collect all the units, to involve all the units in the population. But when the population is infinite, it becomes practically impossible to involve everybody. So that's one of the reasons why we need to use sampling becomes inevitable, because you cannot have a complete enumeration of the entire population, especially when the population is infinite. Number two, when the results are required in a short time. Imagine if you're sick, you're about dying. The doctor cannot go and start extracting all your blood in your system. You have little time. So you have to pick a sample. You just take a sample of your blood and run the analysis. From that particular you can get your result and know what's happening to you. So when the results are required in a short time, because we said one of the disadvantages or demerits of census method is the fact that it requires it requires time, energy, and stuff like that. So, okay, sorry, 1 minute. Hello. Okay, sorry for that. I need to attend to someone. So we say one of the disadvantages of infinite is the fact that it takes time, it takes energy, and a lot of things. So when the results are required in a short time, you use sampling. Sampling becomes inevitable. Now, when the area of survey is wide, cannot cover the whole area, use sampling. When resources for survey are limited, particularly in respect of money and trained person, use sampling. If you don't have enough resources, maybe you don't have a lot of trained persons to enumerators to collect such information, there's not much money and everything, also use that. Then when the item or unit is destroyed under investigation, just pick the remaining sample, the little you can find in that particular place, and then you use it for your investigation. Yeah. So those are some of the things that that we need to use. Okay, please let me attend to something. Okay, yeah, sorry about that. So those are the reasons for selecting a sampling method. So let's proceed. These are the reasons for selecting. So parameters now. Parameters actually are there disadvantages, demerits of sampling. Yes, there is demerit of sampling. Think I'll do that as an assignment. Find out if there's any demerit that is associated. But one of the major demerits of sampling is the fact that when that sample is lost, okay, let's say for example now during transportation or something, once that sample is lost, you have lost the entire information. And that particular, so you have to go back again and everything to collect it. Okay, sometimes the sampling can be destroyed before it even gets to the lab where it's being. We've seen some reports of cases, this NCDC stuff and everything. Okay, so those are some of the demerits of sampling. It doesn't have much, but something has been proven to be the most realistic, okay, type of method of collecting information. Okay, so we can describe samples and populations by using measures such as the mean, median, mode, standard deviation. When these terms describe the characteristics of the population, they are called parameters. They are called parameters. Okay, so we want to describe a sample or a population. Okay, there are certain things we're going to use to measure. Okay, those things are going to use now to measure the characteristics of the population, or those things are going to use to describe the characteristics of the population. They are referred to as parameters. They are referred to as the parameters. Okay, so we have the mean, the median, the mode, the standard deviation, and so many other ones. Okay, all those things that is used to describe the terms that is used to describe the characteristics of the population. They are actually called parameters. So principles of sampling. Principles of sampling. We're going to look at this. There are about 4, okay, of them. As far as principle of sampling is concerned, we have the principle of statistical regularity. We have the principle of inertia of large numbers. We have the principle of validity. We have the principle of optimization. These are principles that the sampling, the not sampling method, these are principles that the sampling method must follow or must obey. Let's discuss them one after the other. Principles of statistical regularity. Now, what we're trying to say is that if you're selecting a particular number, okay, from a population, that number or that average number of the units you selected, which form your sample, must possess the characteristics of the large group. That's referred to as principle of statistical regularity. So anyone that you're picking to represent the sample from that population must possess the characteristics of the entire population. So there won't be, at the end of the day, you're sideline a particular unit or you're sideline a particular persons or item. So when you're choosing a sample, make sure that the sample you're going to choose from the population must represent the entire characteristics of that particular population. That's referred to as the principles of statistical regularity. Okay, that's number 1. I hope you understand that. So when you're taking, let's say for example, what to do the demographic characteristics of people in a particular place. Okay, we talk about demographic characteristics of people as far as age is concerned. And that population, you have people between teenagers, the youths, the adults, the aged ones. So you must pick the sample to represent, you must pick people to represent ages between, maybe let's say for example, between 5 and 16 and 18, which is the 19, which are the teenagers. The ages between 20 and 30 and 40, which are the youth, then ages between 40 and 60, which are the old ones, and then 60 and above, which are the elderly. So you see, if the population has these different ages, you must pick sample from each of these. That's referred to as principle of statistical regularity. Your sample must represent the or possess the characteristics of the large group. So that's number one. Then number two is principle of inertia and large numbers. Other things being equal, the sample size increases, the result tend to be more accurate and reliable. So once the size increases, it becomes accurate. The more the number increases, the more accurate the this thing is. So we have the principles of validity, meaning it can be proven. Okay, it must provide a valid estimate about the population. Okay, that's principle of validity. At the end of the day, it must give us your result must give us a valid estimate or a valid characteristics of that particular population. And of course, the last one is the principle of optimization. Now, this takes account the desirable of obtaining a sampling design which gives optimal results. Okay, so it should be done with little risk or minimum risk or loss of sampling design. Okay, so those are the things that that's what we call principle of optimization. So when you're carrying out your sampling, it must be done with little risk. Okay, it must be done with little risk and must be able to be done. It must be done with some level of accuracy. So that's what we refer to as the principle of optimization. All right, so I think we're going to end the class here, and then hopefully by next week we'll continue from where we stopped. So a quick recap of what we have done. We try to define population, and we said population is actually it represents the entire uh, number or unit of an item or people that falls under the purview of assessment. Okay, and then we looked at we said population can be finite or infinite. We said infinite when the number of the item is countable, but it's infinite when it's uncountable. And then we also looked at we said there are two methods you can actually use to carry out information about the population. You can use the census method, that is when the population is finite. Then you can use the sampling method when the population is infinite. They will look at the merits and the demerits of using both the census method and of course the sampling method. Except for the sampling method, there are four principles that the sampling method must obey. The principle of statistical regularity, principle of inertia of large numbers, principle of validity, and principle of optimization. All right, so we'll stop here today. We'll come next week to continue with the sampling errors and the non-sampling errors. Thank you for your time. See us next week.